Okay, this is Leetcode 3110, score of a string. This is a Leetcode easy problem that is pretty simple if you understand your language's built-in functions, and this was on a previous contest. So we're given a string S. The score of a string is defined as the sum of the absolute difference between the ASCII values of adjacent characters. And we're tasked with returning the score of S. So what's imperative to understand for this problem is understanding what the ASCII values of letters are and how to go about retrieving the ASCII values of letters. And to explain this in the simplest way, it's important to understand how computers represent letters and how computers represent digits as well. So we all know that computers operate in binary. So at the lowest level, computers are essentially just a series of on and off switches, where off could refer to as 1 and on could refer to as 1. So 0, 1, therefore, can be referred to as the digit 1. This would be the base 2 representation of 1. We think of things in base 10, but computers think of things in base 2. And we can obviously, it's amazing that we can represent an infinite amount of digits in base 2 with just a series of on and off switches. The only thing that we are limited by is our memory, which continues to grow. So the amount of digits that we can store on a computer will continue to get larger and larger as computer memory continues to increase. But 0 and 1 refers to the digit 1, 1, 0 refers to 2, 1, 1 refers to 3, and we can keep going on and on. But what's happening here is when we want to perform an operation on, say, a 1, a 2, or a 3, there needs to be some type of translation layer. No one writes code in binary. No one looks at zeros and ones on a screen when they're viewing a web application. So there needs to be some type of translation layer that goes from 1 to 0. So it converts the digit to the binary representation. And this is essentially what the assembly language is doing. Assembly will take whatever the digit is and convert it to the binary representation, where the computer itself can perform operations on the binary representation of the number. So at the lowest level, all computers are really doing is they're doing adds and multiplies, comparing and branching, and loading and storing. So at this lowest level, there's a translation layer. We cannot just simply translate an H to a binary representation. What we first need to do is we first need to translate an H to a digit, and then we need to have a map of those digits that refers to each character, which then each of those digits can then take on this next translation layer to the binary representation. So this is where ASCII, the ASCII protocol, was invented. I believe it was invented in the 1960s when computers started to get a little bit more mainstream. And this was a way to universally map characters to digits. And I believe there was only 128 characters in the ASCII, in the initial ASCII protocol. And now today we use Unicode, which Unicode can represent, I think over 1,000,000 characters, some emojis and different characters like that are represented. But for this problem, we can think of Unicode and ASCII as being synonymous, as the first 128 characters of Unicode are actually the initial ASCII values. So, and as we remember, as we read in the problem description, the domain of the input S is only lowercase English letters, which also simplifies things as well. But all this is saying is there's some type of translation layer from H to a digit, to a decimal, or to a integer digit, and the integer digit to the binary representation of that digit. And all we're trying to do for this problem is go through and retrieve the ASCII value of each character, and once we have that, this problem becomes very straightforward. So all we're going to do when we get into the actual problem is we're going to actually start from the first index rather than the 0th index to avoid an index out of bounds problems. And we're going to take the ASCII value of each, we're going to take the ASCII value of each character, and we're going to take the absolute value and subtract that by the ASCII value of the preceding character, and we're going to have a res variable up here where we're going to just continue to add whatever the absolute value difference is between each one as we go through the loop. And as you can tell, once we get into this code here, the code will be pretty straightforward. So when we get into the code here, all we're going to need to do is we're going to need to initialize this res variable, and we're going to loop through, starting at the first index to avoid that index out of bounds error, and we're going to iterate through the length of the string. Now, what we're going to need to do is, in Python, the way to get the ASCII or the Unicode representation of a character is with the ORD built-in function. That's in the built-in library. And what we're going to need to do here is all we're going to do is we're going to increment res by the absolute value of whatever is at S. So whatever is at index I of the string, and we're going to need to take the ORD of that, which gives us the integer value of whatever that letter is, and we're going to then subtract that by the ORD at whatever is at the index I minus 1. And at this point, that's all we need to do, and we need to just return res. And we'll submit that, and that's accepted. And next thing I'm going to do is just show the C++ code real quick. And what we're going to do here is we're going to initialize this res again. And we're going to loop through, and remember we're going to start at index 1, so int I equals 1, and while I is less than the length of the S. S dot length, and then we're going to iterate I. believe there's only one. I'm going to iterate I. And in C++, we're going to do the same thing as increment res by whatever the ASCII value of the absolute value between the ASCII values of whatever's at that index and whatever's at the index before that. So the absolute value at index I here would be the int of I. In C++, all it is int. Int is the same as org in C++. So we're going to take the absolute value of the int of s I, so whatever character is at the ith index of s, and we're going to subtract that by the int of whatever is at s, the ith minus 1 index of s. And again, that's all we need to do here. We can just return res. And I don't know why I set res to 1. Res should be 0. And that is the right value, or the right answer. And the last thing that we're going to just talk about for this one is what is the time complexity. So the time complexity here is, we're only going to loop through whatever the amount of characters is by whatever the amount of characters minus 1. So all we're going to do here is it's going to just be O of n minus 1 time complexity, which is just O of n. Each, when we take the ord of each value, that's actually an O of 1 time operation. So the time complexity remains O of n, where n is the number of characters in the string. And the space complexity is O of 1, as all we're using constant space. We're just storing this res variable here. And there's the problem here.